So welcome to this technical corner. I'm with Barry Rooney from Prima Power, and we're going to be talking about laser technology. Barry, welcome to the studio. And perhaps you could just give us a quick insight to the origins of laser cutting with Prima Power.
Okay, thank you. So Prima Power started in the late 1970s. Actually, we originated in the metrology industry and then went on in the late 1970s into 3D laser cutting with our first machines going into the automotive industry. From there we developed the technology on and sort of cascaded that down into 2D laser cutting and grew the product ranges, both 3D and 2D laser from there.
So you kind of went backwards in some senses, didn't you? I mean, I say backwards, but you started with something a little bit more advanced than
of course
the 2D. So could you describe the differences between 2D and 3D for those that don't know?
Okay, so with the 3D laser technology, basically what we actually do is we have more of a multi-axis CNC type machine, kind of like a robot that is able to get round a part, however large that part may be, in order to access the peripheries and any components, any areas that want cutting or indeed welding, using a long range head, as you'll see on the video here, that is able to access all of the extremities of the part. With 2D laser, it's slightly different. That's a flat sheet or flat plate application where we're cutting flat product. So we don't need to have, as an advanced situation where we're controlling the head from a Z point of view in terms of its height and its orientation.
And what's the mix in what you sell? Where's two more popular than three?
2D is generally more from a point of view of processing volume parts where you've got a wide range of what a customer might want to do. A 3D application is more for a bespoke type of product application where a customer has a very fixed process requirement. For example, in the automotive industry, that's making a variation or the same part over and over and over again, whereas with 2D that could be making absolutely anything. That's not to say that one isn't more flexible than the other, it's just that the 3D is more orientated around mass volume production or volume production of large components.
So on 3D, what are you really looking for? What's the customer looking for? Speed, agility, accuracy?
Yes, pretty much. So with a 3D application, what you're looking for is repeatability. You want speed, you want high accuracy, and you need an efficient process basically where you can take the part out, put the next one in to keep the process moving, because generally speaking it's based around volume.
And you do have a lot of competition in this field. So what would make people be attracted to your solutions compared to some others? Where do you stand out?
Okay, where we stand out really is the technology that we use. A lot of this technology is our own developed technology. Obviously, it's been developed over a long time. We stand out because of the flexibility we've got in terms of the machines themselves, what we can actually do with them, the automation solutions, the accuracy, the speed, and the consistency in which our machines can operate, because they will just do the same things over and over and over again and get exactly consistent results every time.
Now with laser cutting, obviously the different materials need to be cut. Mm-hmm. You've got the CO2 and the fibre. How do you select which to use per application?
Okay, so that will be application based. Generally speaking, it's to do with materials, it's to do with what the customer's actually wanting to do. The line between CO2 and fibre has become quite greyed, I think, over the last few years as fibre technologies really come on stream. CO2 applications generally tend to be now more with thicker materials, with less laser specific type materials, whereas with fibre you would generally use a more laser grade type material, higher quality. And also with thicker materials, CO2 can be that little bit better in terms of the speed that you would actually get cutting thicker materials. It's not quite so sensitive to the cutting conditions as well.
And what about the surface finish? Because that would strike me as being quite an important factor as well.
Surface finish, generally speaking, with a CO2 laser, a CO2 laser on a thick material, you would probably get a slightly better cut quality. With a fibre laser, you'll get a really good cut quality and a very fast speed on a thinner material. As I say, the lines between those two now are getting a little bit more greyed because the technology is advancing.
It's moving on so quickly, isn't it?
Yes.
Tell me about this new model then, this Genius Plus? Because we've heard about 2D and 3D cutting and all the technology they have, but where's this machine different?
The new Genius Plus is basically designed to take advantage of all of the latest technology. We're a very, very forward-thinking company, so we're always developing new technologies. The Genius Plus is basically designed around what our customers are saying to us that they actually need. They need a fast, flexible, efficient machine. They need something that can go into a wide array of different factory environments. So the layout of the machine is important, the size of it is important. We have used a gantry design this time as opposed to a cantilever, purely and simply for performance and the flexibility that our customers are asking for. They don't necessarily need the advanced cantilever type design. And what that's lended itself us to do is to put it into a more compact layout where we've got a very, very narrow machine with the ancillaries built into it.
And what would they be looking for? What would they need to be doing for this machine to be ideal for their application?
Anything really in terms of any kind of a flatbed 2D laser application. So the machine's very versatile. It's a fibre laser, so it's a flying optic system. It will, depending on what laser power we put onto it, because we've got a wide range of laser powers, a wide range of different material thicknesses. So we can go from very thin materials all the way up to thicker materials as well, with the fibre laser power that we have on offer, and literally every type of application you can think of, from automotive, aerospace, HVAC, refrigeration, subcontract, fabrication, anybody doing any kind of 2D flatbed laser processing.
Because when I look at this style of machine, it always strikes me that one thing you need is obviously the accuracy and the surface finish that we talk about, but it's the reliability as well, isn't it? Because that's really what makes these machines make money when they're not stopped.
Absolutely.
How do you achieve that?
So that's done through a combination of the dynamics of the machine and using the best technology available. So we, as Prima Power is part of Prima Industry, we can call on our other elements in our group in order to use the very best technology that we have on offer from the control point of view. The head is our own, the laser generators are our own. All proprietary equipment that we use is very top technology, so we get outstanding reliability for the machines.
And what really impressed me was when you talked about the software. You've got a lot of options here for streamlining processes, isn't there? I mean, maybe you could walk us through a couple of these things, because it's so important.
It certainly
to
is.
couple it with the hardware.
We're very flexible. So, I mean, if a customer has already got other technology there and they're using somebody else's software, another software house perhaps, we can interface the machine to work with that. We're not completely tied to a particular solution. We then have our own cam nesting software, so we can bring in drawings and parts from other CAD systems, and to create the nests and the tooling paths for the machine to actually run the process. Going beyond the CAM side of things, we then have a suite of other software packages that we can offer. Because the machines are all Industry 4.0 standard, basically we can take data out of the machine and put data into the machine that interfaces up to a customer's ERP system for total traceability through the process.
But you mentioned to me earlier about things like night cut and stuff like that. I mean, the clue's in the name, but I can see why you're trying to develop these things.
So alongside the technology that's in the machine in terms of its mechanical, its dynamic technology, such as the head is completely adaptive, for example. So the head will set itself up for whatever material thickness is being processed. As you can see there, that's got the nozzle changer on it as well. It's changing the nozzles for the different materials. It's checking the nozzle, and then on top of that, it's complemented with a suite of software that options that we can offer, the software and hardware options, basically for optimizing thin materials. So we have like the Smart Cut. The Smart Cut will basically optimize material cutting paths so that we don't have dead time in the process, so it can pierce on the fly.
Instead of going maybe like it takes
absolutely
the quickest
it will take quick to quick point, and it will also avoid collisions. Because with, as you've just seen there on that video there, with laser, sometimes you cut a piece out and it could quite happily flip up out of the material. So the head is designed and the software is designed to avoid going over areas where that would happen. And from that point of view, if the head does have a collision, it's very, very simple and reset. There's no real damage that can happen from it because the head simply just disengages. So we have a safe impact protection system for that, but then we have these suites on top of that are for process optimization, thick materials, thin materials, and the night cut, as you mentioned, is for unattended operation. So the customer can literally walk away from the machine, whatever level of automation it's got on it, confidently knowing that it's going to control itself and give the absolute best performance without stopping.
And that's where we're going to end this one, Barry, on the automation, because this is a part when you have one of these pieces of equipment, you want to keep it running, you've got to feed it.
Absolutely,
yeah. Do it?
So basically, as we've just hit the nice point on the video that's running at the moment, is the machine itself is designed to be, as we say there, plug and play. But then on top of that, there are a lot of different modular automation systems that we can add onto it. So we have the pallet changer. That is literally for just loading on sheet by sheet. That goes into the machine and exchanges itself with the one that's in there. We can put a tower on it. The compact server is a nice one pallet of material in, one pallet of material out. Or we can put a more complicated, larger multi-cassette tower system on there so that we can preload the machine with a lot of material for it to run in automation, and of course it will unload itself with the parts in the sheet as they come out. More complicated than that, if we need to, we can go to a full night train system, as we call it, which is a massive storage system, and integrate a robot system for picking and stacking the parts. So rather than putting them back into storage, we literally take them out, we pick them as they're being cut, and we stack them up so that the customer can then take a pallet of completely cut parts away and onto the next process.
Seems like you've pretty much thought of everything when it comes to developing these manufacturing solutions. Is Prima Power one of the best when it comes to laser cutting technology?
We have been doing this for a long, long time. That's not just to say the laser technology, but also the automation technology at it. So we are up there with the very, very best, from my point of view, this is the best technology I've ever come across in this kind of sector. It really is. It's very innovative, using every level of technological innovation they possibly can to get the very best out of the process for the customer. We're using AI, we're using Internet of Things, we're using Industry 4.0, we use AR, we even use VR for the way that we present the machines, the way we maintain them, and for the machines actually reporting what they're doing back to the systems.
I thought you were going to say they're VAR.
Not VAR, no.
That's it. So laser technology from Prima Power, 2D or 3D, and of course everything else that goes with it, as Barry's spoken about. Contact Barry Rooney. We'll put Prima Power's contact details on the screen. Thank you very much, Barry.
Thank you.